Military historians will mark June 1, 2025 as the day autonomous warfare became reality. Operation Spider's Web wasn't just another drone attack on Russian territory. It was the first verified large-scale combat operation conducted by artificial intelligence systems operating with minimal human oversight during the execution phase, and this changed warfare forever. For over a century, every trigger pull, every missile launch, every tactical decision in armed conflict required a human brain making the final choice. Pilots flew from cockpits, tank crews operated from armored vehicles, and even drone operators controlled their machines from command centers thousands of miles away. The fundamental rule was clear: humans controlled the killing. That rule just got shattered in Russian skies. Ukrainian forces had spent 18 months secretly positioning attack drones across Russian territory using civilian supply routes and wooden shipping containers. These weren't ordinary military operations requiring constant communication with headquarters. The AI systems inside each drone learned about local air defenses, studied weather patterns, and calculated optimal attack routes while waiting patiently for activation. When the coordinated signal finally came, all 117 machines launched simultaneously across 3 time zones without any human pilot controlling individual aircraft. The results were devastating for Russian military infrastructure. 41 aircraft were damaged or destroyed according to Ukrainian claims, with satellite imagery confirming significant destruction at multiple air bases. But the strategic impact pales compared to the technological demonstration. Ukraine proved that swarm coordination across vast distances is now possible using artificial intelligence that makes tactical decisions faster than any human commander could process information. Russian air defense systems struggled desperately to respond to the coordinated attack. Their computers and operators were designed to track large, expensive missiles and fighter jets flying predictable paths. They couldn't handle dozens of small robots attacking from multiple directions while constantly changing course and altitude. It was like trying to swat 50 flies simultaneously while blindfolded. The traditional assumptions about air defense had been rendered obsolete in a single morning. The breakthrough technology enabling these autonomous attacks comes from Ukrainian startup Swarmer, founded in May 2023 and recently securing $15 million in Series A funding from American investors. Their STX artificial intelligence software has conducted over 82,000 combat missions, reducing operator requirements from 9 personnel to just 3 per mission. This isn't theoretical research or laboratory demonstrations. This is combat-tested technology proving itself on actual battlefields. Swarmer's approach represents a fundamental shift from individual drone operations to collective swarm intelligence. Instead of human operators controlling each machine separately, the AI system coordinates entire formations that make tactical decisions as unified teams. Current verified capabilities show operators can effectively manage between 3 and 25 drones simultaneously, with typical combat formations using 1 reconnaissance drone and 2 strike units working together. The technology builds on principles scientists discovered by studying natural swarms like bird flocks and bee colonies. Complex group behaviors emerge when individual units follow 3 simple rules: stay close to neighbors, avoid collisions, and move toward the same goal. When Ukrainian engineers programmed these biological principles into military drones, 50 individual robots became one giant flying weapon that thinks and acts as a coordinated intelligence. Each drone has onboard machine learning hardware that analyzes battlefield data in real time, using particle swarm optimization with neural networks to assign targets within milliseconds. The swarm adapts formations when conditions shift or units are lost. If one drone is downed, others absorb its tasks. These machines communicate over encrypted mesh networks that resist jamming and can fall back to invisible LED optical links. If all external links fail, drones follow stored mission parameters independently. The swarm can continue operations without human oversight, maintaining coordinated attacks, target allocation, and formation control even when fully isolated. They prioritize mission success and survivability. The financial mathematics behind AI drone swarms reveal why this technology is reshaping military power balances so rapidly. Each Ukrainian attack drone costs between $300 and $1,000 to manufacture using commercial components and civilian production facilities. Russian defensive missiles cost between $1 million and $3 million each. This creates cost ratios favoring attackers by factors of 1,000 to 10,000 times. Ukraine's verified production statistics demonstrate the scale of this economic transformation. The country manufactured 1.5 million drones in 2024, with 96.2% being domestically produced, according to Defense Minister Rustem Umerov. Over 500 Ukrainian companies now produce more than 1,000 different drone models, with monthly output reaching 200,000 units by December 2024. This represents a tenfold increase from January 2024 levels, showing how quickly civilian manufacturing can convert to military robot production. Ukrainian officials have announced plans to produce 4 million drones in 2025, though this represents procurement goals rather than confirmed manufacturing capacity. The theoretical maximum assumes unlimited funding and component availability, neither of which currently exists. Ukraine estimates losing 10,000 drones monthly in combat operations, requiring constant replenishment from factories operating at maximum capacity while dealing with supply chain vulnerabilities. The cost advantages extend beyond individual battles into personnel and training requirements. Creating a skilled fighter pilot takes years and costs millions in education, equipment, and experience. If that pilot dies or gets captured, the entire investment vanishes. Training drone operators requires weeks and costs thousands. Replacement personnel can be combat-ready within days. Human soldiers need food, medical care, housing, and extensive preparation. Robots need only electricity and basic maintenance. Traditional military superpowers are discovering that decades of investment in expensive conventional forces may become obsolete. Countries that spent trillions on fighter jets, aircraft carriers, and tank divisions are facing the reality that technologically advanced smaller nations can now field robot armies capable of threatening military giants. The correlation between national wealth and military power is breaking down as AI levels the battlefield. Pentagon officials watched Ukraine's demonstrations with a mixture of amazement and panic. American military leaders realized they were witnessing a fundamental transformation in warfare, and the United States was falling behind a smaller nation using technology that American defense contractors hadn't fully developed. The implications for global military dominance were immediate and terrifying. The Defense Department launched an emergency $1 billion program called the Replicator Initiative, with the goal of deploying thousands of autonomous systems by August 2025. However, the program fell significantly short of its ambitious timeline, delivering only hundreds of systems with thousands more still in production by the deadline. The technological gap between Ukrainian combat-proven capabilities and American development programs became embarrassingly obvious. 7 major defense contractors received urgent contracts to develop autonomous collaborative teaming software. Companies like Anduril Industries, L3 Harris, and Lockheed Martin are racing to build American robot swarms that can coordinate effectively in combat. The Pentagon gave these corporations incredibly aggressive timelines, creating panic throughout the defense industry as they struggle to match Ukrainian achievements. Current American systems include Switchblade 600 loitering munitions, Anduril Altius 600 drones, and various autonomous surface vessels. But military officials privately acknowledge that Ukraine's battle-tested swarms demonstrate more sophisticated coordination capabilities than anything in the current U.S. inventory. The combat experience gap cannot be closed through laboratory testing or computer simulations. Companies like L3 Harris are developing high-autonomy, low-bandwidth control systems that could theoretically allow single operators to manage hundreds or thousands of autonomous machines. But these remain developmental programs rather than operational capabilities. Ukraine's advantage comes from months of actual combat testing that revealed practical solutions to problems American engineers are still trying to solve theoretically. China unveiled its 11-ton Zhutian drone mothership at the Zhuhai Air Show in November 2024, signaling its push into swarm warfare. With a 25-meter wingspan and a 7,000-kilometer range, officials claim it can launch up to 100 attack drones. By April 2025, 4 units were reportedly built, with flight testing planned for June. Yet, China's claim of deploying 100 drones remains unverified, as coordinating, launching, and recovering that many systems from one platform poses massive technical hurdles. Ukraine's strategy instead relies on distributed swarms, showing 2 competing models for drone warfare. Meanwhile, Europe is racing to catch up. Sweden has created systems where a single operator controls 100 drones, while the UK has poured over £350 million into autonomous surveillance. NATO partners are sharing AI research to strengthen coordination across their robot armies. The pace of change is historic, reshaping how wars are fought. Traditional advantages like geography, manpower, and industrial scale now matter less than cutting-edge AI. Smaller nations are seizing this opening. Israel, South Korea, and Taiwan could field robotic forces strong enough to threaten bigger adversaries. Even Estonia, with under 1.4 million people, could challenge Russia using AI swarms, redefining global military power. The most disturbing aspect of AI drone swarms isn't their battlefield effectiveness or economic advantages. It's their growing independence from meaningful human control over life and death decisions. These machines are crossing the threshold from tools operated by humans to autonomous weapons that select and engage targets with minimal human oversight. Current Ukrainian swarms still require human authorization for lethal strikes, but the technology already exists to bypass that step. The U.S. Department of Defense's Directive 3000.09 demands human judgment in autonomous weapons, yet exceptions exist. Defensive platforms like Phalanx and Iron Dome operate independently under narrow conditions. As AI advances and battles compress to millisecond decisions, the boundary between human-supervised and fully autonomous grows thin. These systems don't just execute orders, they learn. Machine learning allows drones to study each strike, recognize defensive patterns, and adapt tactics without guidance. With every engagement, the swarm evolves into a more effective killing machine. Analysts fear this adaptive intelligence could eventually produce capabilities beyond what engineers designed, raising the risk of conflicts escalating without human oversight. The targeting potential is staggering. Computer vision enables drones to recognize individuals with facial ID, while GPS precision locks onto vehicles or buildings. In theory, swarms could carry out surgical assassinations while minimizing civilian harm. 51 nations have signed pledges on responsible AI warfare, but none are binding. With technology racing ahead, diplomacy risks regulating weapons that are already obsolete. The revolution in robotic warfare has crossed a line that no one can erase. Ukraine's battlefield use of AI-driven drone swarms proved that autonomous systems can outmaneuver and defeat traditional militaries. That single demonstration opened the floodgates to a global arms race, where every major power is now developing swarming technology, and there's no stopping it. Still, the technology isn't without weaknesses. Nearly 89% of drone components are made in China, creating a fragile supply chain that could be cut off at any moment. But the real breakthrough isn't in the parts. It's in the science. Swarm coordination, autonomous targeting, and adaptive learning are ideas that can't be put back in the box. Once shown to the world, they become part of every nation's military playbook. And the impact doesn't end on the battlefield. The same AI systems that make drone swarms deadly can also make civilian industries smarter. Logistics, shipping, transportation, disaster response, even infrastructure repair are now shaped by the same core technologies. The line between military and civilian robotics is disappearing fast. The old tools to regulate warfare, international laws, ethical guidelines, treaties, simply can't keep up. By the time rules are debated, the technology has already moved forward. Institutions built for yesterday's wars have no control over today's reality, and as AI pushes warfare into a new age, the world is left searching desperately for countermeasures that may never come. But while the world scrambles to counter drones and swarms, another threat is rising in the skies. China has unveiled its new sixth-generation fighter jet, and the technological edge it claims could change the balance of air power forever.